Let's talk about economics. I'd like you to start by thinking about this question. What do you think of when you hear the word economics? When I've asked this question in the past, I get responses like the stock market, gross domestic product and unemployment, supply and demand, money, and those are definitely things that economists study, although it's actually a very small set of economists that study those well-known topics. Because most economists actually study a lot of different things in a lot of different fields, what we would think of as different fields. So let's talk about the most general definition of economics that we can all agree on, all economists can agree on. This is what we're going to use for this class. Economics is the study of how people choose to use scarce resources. That's what economics is. It's how people choose to use scarce resources. In order to understand this definition, we need to define scarcity. That's the root of this definition, and so we need to make sure we know what an economist means by a scarce resource. In normal English, scarcity just refers to having a limited amount of stuff, which is pretty close to what economists mean by scarcity, but we need to expand that definition a little bit. If you think about scarcity in your own life, you might think about money. If you are a full-time or even a part-time student, you likely don't have a full-time job that pays really well, so you probably feel that money is scarce. You probably also feel that time is scarce. But a lot of other resources you might feel are abundant. You have an abundance of options at the grocery store or an abundance of entertainment options on TikTok and social media and YouTube and whatever streaming services you subscribe to, etc. Those can all feel very abundant. But in economics, most resources in this world are scarce because we define scarcity as having limited resources in the face of unlimited wants. So if we look at one resource, say time, it's a limited resource because there's 24 hours in a day. But if you are a lazy bum who doesn't plan to do anything in that 24 hours might seem abundant. But in economic terms, every resource that we have can be used in a lot of different ways. So in that 24 hours for a normal human being, you can, or for your kind of situation, you can go to school, or you can go to work, or you can spend time with family or friends, or you can work on homework, or you can bake cookies. There's a bunch of different things that you can do with that 24 hours. And so time is limited in the face of all these choices that you have to make. This can also apply to something like water. Water might seem abundant in a place like Portland, Oregon, where it rains a lot and you're next to the ocean. But even water is scarce in the sense that there's a bunch of different ways that we can use that water. We can use the water for farming, we can use the water for showering or doing the dishes or drinking. There's a bunch of different ways that we can use the water, and so there's a limited amount of that water in the face of the plentiful ways that we can choose to use it. So that's how in this definition, economics definition of scarcity, any resource becomes scarce because any resource can be used in a lot of different ways, and once we choose to use it in a certain way, it can no longer be used in any of those other ways. So let's see how this definition of scarcity leads to this definition of economics, the study of how people choose to use scarce resources. Economists like to ask, what's the best way to allocate scarce resources? If every resource is scarce, what's the best way to use those scarce resources? The method that economists have come up with to answer this question is by using what we call marginal analysis. You might know this better as cost-benefit analysis, and marginal analysis is pretty much cost-benefit analysis, except that Rather than looking at total costs and total benefits, we look at marginal costs and marginal benefits. This marginal just means the extra or the additional. So the marginal benefit is the extra benefit of using one more unit or consuming it or making it. The marginal cost is the extra cost of using one more unit of the resource. So just remember, marginal means extra or additional. So when we're using marginal analysis, we're looking at the extra cost and the extra benefit of this activity that we're considering. Let me go through an example of this marginal analysis. And once I finish this example, I want you to ask yourself, and I will ask out loud, whether you think that this example is economics. The reason why it might not seem like economics is because it's about basketball. I am not like a sports person. I don't watch sports. So as I talk about this article from this website called 538, which is a fascinating website that uses a lot of data analysis. If you're into data and analyzing data, this is a wonderful website. Anyway, so as I go through this article from 538, I might be using terms that are not technically correct if you are a professional basketball player or really into basketball. So forgive me for that. So this data analyzer, Kirk Goldsberry, gathered a bunch of data from the 2014 to 2015 NBA season. The first thing that he did with this data is he plotted a point for each shot location. So each of these dots on this diagram shows where a shot attempt was made. It doesn't matter whether the shot went into the basket or not. It's just each point is a shot attempt. As you look at this diagram, do you see any patterns? Feel free to pause the video if you'd like to analyze the data on your own first. But as you look at this, it becomes pretty clear that there's a cluster of shot attempts really close to the basket. It kind of thins out as you get further from the basket until you go past the three-point line, and then you get a whole bunch, another big cluster of shot attempts. So that's a pretty interesting pattern to notice just from this first attempt at data analysis. Now let's bring in some marginal analysis. So let's see what Kirk Goldsberry does next to explain why there's a cluster here and clusters here. So the next thing he does is he does the field goal percentage. So he takes each shot attempt and then and adds to that shot attempt whether the shot went into the basket or not, whether the shot was made or not. So on average, shot attempts in this area, the one closest to the basket, those shots go into the basket over 60% of the time on average. A little bit further out, it's 55 to 60% of the time, and then it gets a little bit less as you get a little further out. These ones on the side are pretty horrible. They're only made 35 to 40% of the time. And past the three-point line is also pretty bad. They only go in 35 to 40% of the time. So you can think of this diagram as representing the cost of making a shot attempt. Let's actually back up a little bit and think about what is the scarce resource in basketball. Again, you can pause and think about it if you'd like some time. So there's, a fair number of scarce resources. There's a scarce number of players on each team. There's or who can be on the basketball court at a time. There's a scarce number of balls. I don't know if that particularly matters if you're a basketball player, but there's only one ball that everyone can play with. But the most relevant scarce resource is the amount of time a player can hold the ball, or each team can hold the ball. Again, I'm not super clear on all the basketball rules, but there's a certain amount of time before a shot attempt has to be made. So That's the main scarce resource, and the cost of that scarce resource is how likely it is to go in. So when you have the ball and you know you have a limited amount of time to make a shot attempt, you might be thinking about, okay, these are the likelihoods of the different areas of the court. Where should I position myself to minimize this cost of making the shot attempt? So that's the first one side of the scarce resource allocation decision. And what's the benefit of making a shot attempt? Well, it's the points that the team gets. So that's the next diagram that we're going to look at, is the points per shot. So once you take into account the likelihood that the shot attempt goes into the basket, multiply that by the number of points you get for shooting from that location, then you get the average points per shot from that location. So because these shots are likely to go in, by like 60% likely to go in, that means on average, since a shot from that location is worth 2 points, on average, a shot attempt from this location will give you 1.2 points. So some will go in, some won't, but so on average, once you take all those shot attempts, you'll get 1.2 points per shot. This area, because these shots are less likely to go in, but they're still worth 2 points, you get under 0.85 points per shot if you make an attempt from these areas. Remember that past the 3-point line, you're still not very likely to make this shot, but each made shot is worth 3 points, which means that on average, shot attempts from this area are worth between 1.1 from these sides here and 1.05 from back there to 1.2 points per shot. So even though you're less likely the cost is higher out here, the benefit is also higher because you get 3 points per shot rather than just 2 points. So now if we combine that cost and benefit analysis, we get the points per shot and most common shot locations. And as you'd expect, the most common shot locations are happening where you get the most value per shot attempt. In other words, whether consciously or subconsciously, most likely somewhat consciously, because basketball teams do have people who analyze data like this, players are mostly shooting from places where they know their scarce resource is going to go for the best advantage. They're looking at the extra cost, that the risk of not making the basket versus the likelihood of making the basket, versus the extra benefit, the extra points that you get per shot attempt. So they're doing that cost benefit analysis, that marginal analysis, to decide where on the court they should shoot from. If you look at the history of basketball, it's actually interesting because prior to the 3-point line, most shot attempts were happening right here. And if you watched a game of basketball, you probably know that these types of shots favor tall players because they can dunk or play over the shorter players and are therefore more likely to make those baskets. And so most basketball games before the 3-point line were happening right around here. And the NBA big wigs were afraid that the game would get boring. And so they decided to create the 3-point line in order to allow shorter players to have a shot at, doing something interesting and making the game more interesting to watch. But one of the complaints nowadays is that most of the action is happening out here, which is far less interesting in some ways than watching a lot of action near the basket. And so the game kind of moved the other direction in terms of how interesting it is to watch. So this kind of illustrates another economic point, that people respond to incentives and they don't always respond in a way that you expect or would like. So got to be careful with economic incentives. So now let's go back to my original question. Is this type of data analysis, is this type of decision-making economics? Hopefully, because I used a lot of economic terms, you conclude that, yes, this is economics. And indeed, there are economists who focus on sports. They are sports economists. We also have environmental economists who study the environment, global warming issues, etc. We've got labor economists who look at a variety of issues from, getting a job to inequality in the workforce to education, which is mostly about preparing people for jobs. So economists study a wide variety of topics using this idea of scarcity as its basis and using marginal analysis to figure out the best decisions to make. In this class, we will mostly just be doing traditional economics, which focuses on supply and demand in a market where there's a buyer and a seller. So kind of the more typical thing that you think about when you think about economics. But I just wanted to let you know that economics is a big and varied field that can do a lot of exciting and interesting things with scarcity at its foundation. Let's talk a bit more about this marginal analysis, and specifically how we can use marginal analysis even in our own lives to make good decisions. Optimal decisions is the word that economists like to use. This result is a very important result. We're going to see it again and again throughout the whole semester, which is why I'm stating it at the very beginning. Optimal decisions are made where the marginal cost is equal to the marginal benefit. Let me go through an example of what I mean by this, how you can use marginal analysis to come to this conclusion. Let's think about making and eating cookies. Let's think about first the marginal benefit of making and eating another cookie. So when you eat a cookie, you get some satisfaction, some pleasure from eating that sugary, gooey bit of goodness. So the extra benefit that you get from eating one more cookie is that what's going to happen as you eat more and more cookies. So the first cookie is going to be really, really good. It's very, very satisfying. If you're like me, who has a fairly low sugar tolerance, then eating the second cookie is definitely less satisfying. It's mostly just really sugary, and I have to drink a lot of water to kind of bring it down. And if I eat a third cookie, then I start to get a headache. So again, I have very low sugar tolerance. So the extra benefit of eating one more cookie will decrease as you eat more and more cookies. In other words, as the quantity of cookies that you eat increases, the marginal benefit of eating, that extra benefit that you get from eating that one more cookie, will start to decrease. This is true for pretty much any situation. The extra benefit of doing an activity will decrease the more you do that activity. Let's next think about the marginal cost of making one more cookie. So think of some of the costs of making a cookie. You need to have an oven, you need to have a way to mix the ingredients, you need utensils for making all the cookie dough, and then you need the ingredients for the cookie dough: flour, sugar, butter, eggs, etc. If you want to make more and more cookies, you'll eventually need to acquire more and more of those ingredients. So as the quantity of cookies that you make increases, eventually the marginal cost of making one more cookie will increase. And again, this relationship, that marginal cost increases as the quantity you produce increases. That's true in pretty much every situation. The more and more you produce of something, the more the extra cost of producing will go up. Let's look at these relationships of marginal benefit and marginal cost graphically. So I'm going to draw a diagram with quantity on the x-axis, quantity of cookies, and then the marginal benefit and marginal cost on the y-axis. So we said that as the quantity goes up, the marginal cost increases, so that's an upward sloping line. As quantity increases, the marginal benefit decreases, so that's a downward sloping line. Now let's do some marginal analysis. Suppose that we make 3 cookies. And the marginal benefit, the extra benefit of eating the 3rd cookie brings me approximately $7 worth of satisfaction. So you can think of this as I'm willing to pay $7 because that's about how much satisfaction I get from the 3rd cookie. The marginal cost, however, of the 3rd cookie is only $2. So it's a low marginal cost to begin with because I probably already have most of the ingredients and definitely have like the oven on all the utensils. So the extra cost of making that 3rd cookie is pretty low. So is it worth it for me to spend time and resources making this 3rd cookie? If we're thinking of cost and benefit, the extra benefit is $7, the extra cost is $2, so it's pretty clear that it's worth it to devote resources, my scarce resources, to making this 3rd cookie. I can kind of do the same thing with the 4th cookie or the 5th cookie. I can see from the graph that the marginal benefit of all of these cookies is greater than the marginal cost, so they're all worth my time and scarce resources. Let's skip to over here. Suppose I make 8 cookies. I'll try to make the numbers slightly different. So this tells me that the marginal cost, because I'm on the marginal cost line here, the marginal cost of that 8th cookie, say, is $6.5, whereas the marginal benefit is $1.5. So by the 8th cookie, I'm kind of getting sick of the cookies. I only get an extra $1.50 worth of satisfaction from the 8th cookie. But by the 8th cookie, I've started to need to buy more ingredients or whatever I'm running out of. And so the extra cost is $6.50. So same question, is it worth it to devote resources to producing the 8th cookie? Pretty clearly not, because it costs, the extra cost of that 8th cookie is quite a bit higher than the extra benefit. So it's a waste of resources if I make the 8th cookie. So if this area, these cookies are all worth making, and then in this area, all these cookies are not worth making because the extra cost is greater than the extra benefit, then it's pretty clear that the optimal number of cookies to make is the quantity where the marginal benefit is equal to the marginal cost. So that's what I meant by this optimal decision here. The reason why this optimal decision is where the marginal cost is equal to the marginal benefit is because if the marginal cost is less than the marginal benefit, then you should keep doing it and keep increasing what you're doing because the extra cost is greater than the extra benefit. If the marginal cost is greater than the marginal benefit, then you need to stop doing it and decrease that activity because the extra cost is greater than the extra benefit. And so where they're equal is the optimal amount. If you have done any kind of economics before, this diagram probably looks familiar, just with different names. So if I were to call this marginal benefit curve the demand curve, and this marginal cost curve the supply curve, and I were to call this the equilibrium quantity, and this the equilibrium price, and have price on the y-axis and quantity on the x-axis, then this would be your typical supply-demand diagram. And it's actually, by the end of the semester, we'll see that indeed these are the same diagrams. The demand curve in a market diagram does reflect the marginal benefit of consuming that good. The supply curve is the marginal cost of producing that good. And because supply is marginal cost and demand is marginal benefit, that means that this equilibrium quantity from a marginal analysis standpoint is the optimal quantity. It's the optimal way of allocating our scarce resources. This result that the equilibrium quantity is optimal is only true under certain conditions that we'll talk about by the end of the semester. But this is, again, a very important result, which is why I'm showing it to you right at the beginning. Markets are really good at allocating scarce resources. And so that's why economists spend most of their time looking at markets in order to answer this question of how do we allocate scarce resources. Sorry, going back to here. So this discussion that I've gone through in this video covers the in the very first topic, T0 for this class. It covers the scarcity learning outcome and the marginal analysis learning outcome. Please let me know if you have any questions or concerns about any of these topics.